Hi guys, welcome back to Math Thingy. So after we known about sets and subsets, we're gonna talk about set operations in this video. So before we jump into the set operations, I want you to note for the universal set, which is like the general set that all other set belongs to. So that's really a simple definition of universal set. And we are going to go through the Venn diagram, which is like illustrations between these operations and between set and subsets. But we're gonna have the Venn diagram and the subsets in another video. In this video, we just talk about simple set operations such as like the additions, subtractions, multiplications, and divisions in our like numbers operations. So first of all, for example, let's say we have three sets. Set A, which is number from 1 to 5. Set B is the even number from 1 to 5. And set C is the odd number from 1 to 5. So the first definition is the intersections of the two sets. So the intersections of two sets X and Y is the set of elements that are in both X and Y. So that's very simple, right? It's just like the intersections between lines. So note here that the intersections is the set of elements that in both X and Y. The both is like a special term here. So in math annotations, this is how we denote. So let's call W is the intersections of X and Y. For intersections, we denote is as like the upside down U, which is intersections X intersect Y, so that every X element, X belongs to X, and small x belongs to large X, and small x belong to Y. So that's the intersection. So in our example here, we see that A intersects B, example here, A intersects B equals 2 to 4, right? And A intersects C equals 1, 3, 5. But B intersects C equals the empty set. So here's a new concept here. So the empty set, we call this an empty set or a null set, is the set with no elements. And this is how we denote the empty set, with like the 0 and a cross out. And like if two sets is the two set intersections is an empty set, we can say the two set is disjoint. So here we're gonna say B and C are disjoint. Okay. For the next definition, it is the opposite of intersections, which is union. So the union of two sets X and Y is the set of element in one or other set. So note the difference here. For the intersections, it is for both. So like the elements have to be in both sets. But the union here, we just need to in one of the sets. So that's the difference between the union and the intersections. So for the union, we're gonna denote it as the U. So let's say V is the union of X and Y, which is, so we denote like for every X, every element X, so that X belongs to X or X belongs to B. So note the different how we denote the intersections and the union here. For the intersections, we use the and, but for the union, we use the or. So note that. For the next definitions is the complement. So the complement. So we say the complement of set X is the set of element of the universal set U that are not elements of X. So note again that the universal set U is the set that all of the other set belongs to. And how we denote the complement of set X is X with like a line above its head. X. And in mathematical way, here we denote it as so that for every X belongs to the universal set U, X is not belongs to X. That's it. That's it for the complemental. The next definitions is the relative difference of X and Y. So we say the relative difference of X and Y is the set of element X and X of element that are in X but not in Y. So of X that are not also in Y. So it's kind of simple terms like our subtractions in numbers, and we denote it at the same as our subtractions, which is X minus Y here. So we have X minus Y equal to all X that belongs to the universal set U, so that X belongs to the larger X and X is not belong to Y. That's the relative difference of the two sets. The next one is the partitions of the universal set U. So the partition of the universal set U is the collections of disjoint subsets of U. So, and which means that the union of the subset is U. So let's say U have a subset of X, I, J. No, actually just Xi, where I is equal to 1, 2, to n. which means like the universal set U has like n subsets, and there's no I, and there's no two subset that has a common element, which means the intersections between two random subsets of U is the empty set, which I, J here is equal to 1, 2, 2, n, right? And because it's the partitions of the universal set, the union of every subset equals to U, which is the universal set. Here, x4 union to xn equal U. So that's how we define the partition of the universal set U. And for the partition of like just one random set, it's also like it's a collection of set that its union is the original set, and there's no two subsets that intersect each other. And last one is the power set. The power set is the power set of, let's say the power set of a set X is the set of all subset of X. Which is denoted as row X. It's like P in like the Greek alphabet. So we denote the row PX is A. So every set A, subset A, that A is the subset of X. So A is a set. So let's say find the power set of X equal 1, 2, 3. So we're gonna have the row PX over here is set 1, subset of 1, subset of 2, subset of 3, and then 1, 2, 2, 3, and then 3, 1. And then every set is a subset of itself, so we're gonna have X also as a subset, and every empty set is a subset of all sets. Note here, like empty set is a subset of every set. So we see the PX, the number of PX has 8. PX has 8 elements, which exactly 2 to the power of 3 elements. So we have to prove that for every subset, for every set X that has an element, we can prove that X has 2 to the power of n subsets, which means the PX, the power set, has 2n elements. So that's the basic sets operations for in this video, and the next video is the Venn diagram with the subset, which will clearly demonstrate that in a more visualizing way for you guys. So comment below if you want me to make one more video to have a proof for this 2n subsets power set here. So if you have any questions, also comment down below. Okay, thank you for watching, and I hope you guys enjoyed this video. Remember to like, share, and subscribe.